Hi there, I'm TexasTim.dev, and this is my ongoing project to grind through all the algorithm problems on LeetCode. So thanks for joining me today. Why don't we hop on over and see what problems are available today? I've done just about all the easy ones. Sometimes they add a new easy one, so it's always worth checking. Let's see, let's check the easy. I never say no to an easy one. Ooh, there is an easy one. Why don't we knock that out? And look at that, 74.8% acceptance. So that's going to be an easy one, we can hope. Alrighty, 1935, maximum number of words you can type. There is a malfunctioning keyboard where some letter keys do not work. Interesting. I like these real world scenarios. All the other keys on the keyboard work properly. Given a string text of words separated by a single space, no leading or trailing spaces, and a string broken letters, so they're going to give us the broken letters, okay. Return the number of words in text you can fully type using this keyboard, okay. Where my mind went as they were describing the problem is I thought that they were gonna give you the output showing the missing letters. Like, let's say O was broken, then it would be hell world, WRLD, and maybe they would include a dictionary of correctly spelled words. And so you'd have to check the words that are missing letters in the input variable text against the dictionary and figure out what are the broken keys. That would be another interesting one. It's not what they asked, but that would be interesting. What they're asking is a little bit easier. It really is. I'm already thinking we're going to take the input string text and we're going to split it up into words, and then we are going to see if it contains any of the characters in broken letters. If it contains any of those letters, then it is not a word we can type. We can type fully with this broken keyboard. If it does not contain any of those broken letters, then we'll increment our return variable because it is a word we can spell. So why don't we get on that? All right, we're gonna have to keep track of words we can fully type. That'll be 0. All right, and that's actually also what we're going to return. So we can come down here. Boom. That's basically it. We can pass this on now to somebody else. Haha. Just kidding. We have to fill in the middle. Okay. I'm thinking that we store the broken letters in some data structure that offers us really fast lookup. So I'm thinking a set character, broken letters. I'm trying to remember if Java is going to be bothered by a set named broken letters and a string. Let's see, Java can 2 different data types have same name. You cannot have variables with the same name, okay? That's what I thought, because it might try to cast one to the other or something. And so you wouldn't want to do that. All right, so we'll call it broken letters set. All right. Populate broken letters set. All right, and then we'll add C, and that'll enable us to do some Very fast lookup. I guess we should initialize it, shouldn't we? Why not? We'll do a hash set. Reasonable option there. What else would there be? A tree set. We don't need to preserve the insertion order. That's not necessary. Is that a, no, tree set? Tree set orders it according to its natural ordering, I think. This should be a quick video because this is an easy one. And yet if I keep running down these rabbit trails and opening Google to check these other Java questions, this video is going to be way too long. So hash set is going to be just fine. Now let's split text into it's words. And what is it? Separated by a single space. So I think that should work. I think that will work. Let's make sure. Let's run this and see if we get a list of the words. And we do. All right, so that's all good. Okay. So now, each word in words and text. And I want to use a method to sort of keep the code clean. So we'll do if can be fully typed each word, then increment words we can fully type. See, if you choose good variable names, your code is totally self-documenting. All right, so that should all work, but now we need to define can be fully typed string word. Okay. And here we're going to go through char C and word to char array, and if any of these characters appears in the broken letters set, then we can return false. And if we loop through the entire word character by character and we never return false, then at the end of that loop we can return true. So let's see. If let's copy the name of that set. If broken letter set contains C, and return false. And if we get all the way through, if we didn't return false earlier, we can return true. Always a nice thing to be able to do. All right, let's take a look at our code and see if there are any what I like to call stupid mistakes, like what would it be, like missing a semicolon, misspelling a variable name. Okay, broken letters is what they give us. Broken letters set. And then words in text, each word in words in text. If can be fully typed, each word. It looks like COBOL or some kind of really old programming language that tries to use natural nouns and verbs to encode the business logic. All right, words we can fully type. I think it's going to work. Let's run the code. Let's see if it works. Nice. We can, and I can just eyeball and see that hello is the word we can type and world has that D. Well, let's submit. Yes! I like it. I like it. 1 millisecond. Faster than 100%. I'm guessing a lot of people are at that 1 millisecond mark, is my guess. Let's take a look. I am curious. Yeah, look at that. We're all up there. Although, that's interesting that there's a little bit of a cliff there. Let's see what the people here... I mean, this is what I did. Wait, what is... Oh, that's funny. Oh, that is interesting. That is interesting. How... I suppose that would work. That's funny. That's a nice... I mean, that's more succinct code. So what I find interesting is that they increment ands, but then they decrement. No, that's okay. Let's see. So they increment it, but then they take it away. That's funny. I guess I did it the other way. If it contains it. At least they break, so they're not, looping through unnecessarily. That's interesting to me, though. It feels like there's some amount of, what would you call it? Not exactly redundant code, but like backtracking and undoing what you did earlier. And that kind of rubs me the wrong way. But in the main, it's the same idea. Let's look just one more down and see what's down here. So here is a little bit more manual of a traversal. They do still, break early, which is good. It's part of the looping condition, because you don't want to keep looping after you already know, whether the word can or, I guess once you already know that the word can't be spelled. That is cool. All right. Well, and of course, the thing with LeetCode is when you submit your solution, it goes to, I guess, the LeetCode judge. And I assume, depending on how busy the server is, you might get a faster or slower runtime. I mean, I've certainly submitted the exact same code, either in succession or at different times and gotten different runtimes. That's what, I wonder if I would get a 0. Did anybody get 0? Nobody got 0. Let's see what happens if I submit it again. Same. Cool. Well, that was fun. Hey, thanks for hanging out with me while I work on this easy problem. And catch me next time. Probably there'll be like a medium problem that I can work on. In the meantime, if you want to hit like and subscribe, if you want to keep up with this project I'm doing, if you have any questions or suggestions about anything in this solution or this particular algorithm, feel free to pop those down in the comments. I'd be happy to hear what your thoughts are, and I will catch you on the next one. Thanks. Bye.